Recording. Okay. There we go. Okay. So as an introduction to electricity, we're going to talk about how it works. Electricity is when electrons move through a conductor. So a conductor, usually like in the things we do is metal, but other things do conduct electricity, like water conducts electricity, but that doesn't really make a circuit of the type that we're talking. We've got two main types of things. We've got conductors, which for our purposes are like wires, metal wires, and then we have insulators, which are the plastic that surrounds the wires. So take like any of your power cords, when you're holding the power cord, it's plastic and the wires are inside. That keeps us from getting shocked. Here is a simple circuit. We've got batteries down below and these two wires that go up and connect to the sides of a little component that has a light bulb on it. So that's a very basic circuit. I know I'm just ripping along, but we'll slow down in a sec. Here's a circuit of the type that you'll be doing, you'll be creating in Tinkercad. This one, I like it a little better. You've got a battery. And it connects with one wire to one side of the light bulb, and then the other side of the light bulb goes to a switch. That's what that little weird thing is over there. And then from the switch, it goes to the other side of the battery. And the two most important parts of this circuit are the source. That's where the power is coming from. And then the load, that's what's using the power. And in this case, the source is the battery, right? I mean, I think that makes sense probably to most of you. And the load is the light bulb. The load is not the switch. The switch is not a load or a source. So I'm not telling you that things are always one or the other. I'm saying in any given circuit, there would be at least one source and there'll be at least one load, but there can be plenty of things that are not sources and that are not loads. But in the diagram, in the little picture up here, the battery is the source and the light bulb is the load. I'd like you to now, let's give on the chat, can you just pop into the chat some other, first, let's talk about other, besides batteries, where we can have power come from. What are some other power sources? Chat to the whole group. Yeah, the sun, sure, yeah. Water power, like hydropower, solar, air, you mean like wind maybe? Power plants can run on coal, natural gas, nuclear, fossil fuels. Yeah, good. And yeah, heat can generate electricity, just straight up. Yeah, good. You guys did great. So we can stop. Awesome. Lots of great ideas for where power comes from. Let's put some examples of other loads in the chat. So the load in this example is a light bulb. What are some other loads? A fan. Yeah, monitor, light, computer, your telephone, the computer you're using, your internet router, the television, the lamp, your refrigerator. Yeah, a Bluetooth speaker. Yeah, good. Awesome. So this was the slide I got from the We Share Solar people. Electric source examples, battery, nuclear power plant, solar panel, diesel generator. I added a car power port, the charging port in a car where you can charge your phone. I mean, I know that's coming from gasoline, but it's still, it's a source for a particular circuit. And then electric load examples, light bulb, motor, computer. And then get this, battery can be a source or a load, depending on whether you're pulling power from it. That's when it's a source. Or it can be a load if you're charging the battery. And Marcus, maybe you're saying only some batteries, but yeah, I'm talking about the batteries in the solar suitcase that can be charged or drained, and so definitely not every battery can be a load, but for our purposes with the solar suitcase, the battery can be a source, supplying power, or it can be a load drawing power if it's charging. So let's take a look at this. Here's a little picture diagram of a solar suitcase, and it's a solar panel on the left. And there's a battery kind of right in the middle there on the bottom, that white thing. And then there's this light. The light's not on right now. So in this setup, the solar suitcase is charging on a sunny day. Let's say, what is the source and what is the load? So you can maybe unmute yourself and just go for it.
The sun and the light, or the sun is the source and the light is the load.
Well, right now the light's not on, but the battery in this case is the load because we're charging the battery during the day. Yeah, but you'll see in the next slide, you'll be able to see, oh yeah, the light's on in the next slide. But yeah, so right now the ultimate source is the sun, but for this particular circuit, the source is the solar panel. Solar panel is providing the power. And then the battery, we're putting power into the battery. We're charging the battery. So here's a different scenario. And you can see I turned on the light and made it yellow. Now it's nighttime. Somebody else, what's the source and what's the load?
The source is the battery and the load is the light bulb.
Yeah. So here we go. We talked about how the battery can be a source or a load. The type of electricity that we're going to be using is called DC, or direct current. This is what solar panels produce and what batteries give you. And all of our electronic devices actually use DC inside, whether it's a phone or a computer or a monitor, that sort of thing. The other type of electricity, the main other type that gets delivered to our homes is AC, alternating current. And this is the type of electricity that comes out of the outlet in your wall. And you might be thinking, okay, well, I plug my Chromebook into the wall. So doesn't my Chromebook run on AC? But here's the thing. If you look at your Chromebook, you've got this, you plug it in, and then there's a little brick thing in line. That actually converts the power. Yep, Marcus is holding his up. That converts the power, thank you, Marcus, from AC to DC. So then the smaller wire usually that comes out of that brick that goes to your computer, that's providing DC to your Chromebook, because your computer doesn't want AC, it wants DC. So and then bigger appliances like a television or a monitor have that converter built in on the inside. So you don't always see that brick thing, but all of our modern electronics for the most part use direct current inside. So just so you know, a DC circuit has a positive side and a negative side. So we literally use the plus sign and the minus sign. You've probably seen it with batteries. One end of the battery has a minus, one end has a plus. So that confirms it's direct current. The thing about alternating current is it's just nuts. Alternating current moves the electrons through the wire one direction, and then it changes direction. It moves it back the other way, and it changes direction 60 times per second in the United States. It does it different rates in other countries, but so the power is just going back and forth, and that movement of the electrons, like through a light bulb, makes the light bulb, light up. Whereas in direct current, the power is just going in one direction. It's going from the plus side through the object to the minus side. So yeah, DC is simpler to understand. AC is just kind of crazy, but the main reason we have the two types is they are two types that exist, but direct current can't be sent very far over wires. So but alternating current can be sent efficiently, miles and miles. That's how they get it to our home. And then you can't transfer direct current like that a long distance. It loses a lot of power. So anyway, crazy. So every circuit in the solar suitcase has a positive side and a negative side, and both sides need to be connected for things to function. We think of it like a loop, really. And if either side, the plus side or the minus side, is broken or separated, then the circuit won't work. And that usually happens with a switch, unless you've made a mistake. So here's a kind of crazy diagram. This shows almost, this is probably 3/4 of the wires that are inside of our solar suitcase. There's that big black thing on top, that's called a charge controller. And then you can see 2 wires that go from the charge controller over to the solar panel. And there's a switch in there because you might want to be able to turn off the solar panel's, input. And then in the middle, there's a battery also connected to the charge controller on separate wires with a switch. And then over on the right, there's the load, and it's connecting to the charge controller separately, also with a switch. So yeah, so this is how things work with the solar suitcase. I mean, it's prettier than this, but the last funky thing here for today is if you connect the positive and negative sides of a battery or a solar panel together without putting a load in between, you're creating what's called a short circuit, and that can be dangerous. So don't ever connect the plus and minus of a battery together. See the little flame icon here. Not a good thing. So those are the basics of what we're talking about with electricity today. I want to just show you before I post the assignment. If you log into Tinkercad, then not right now. We'll do it. You'll get to do it in a minute. Over on the left, there's 3D designs, but then there's a area we haven't gone to before as a class, and it's called circuits. So when you go to circuits, then you can say create a new circuit, and then you can create a circuit, and then there's little pieces of things. Instead of having blocks and cylinders and spheres, you have these electrical parts over on the right. So for today's assignment, I'm asking you to grab a slide switch, and then a regular light bulb, and then finally a battery, a 1.5 volt battery. And then I'm asking you to connect them with wires. I show you how to do that. I post a little video. I also want to show you, as part of today's assignment, I want you to test your circuit. And it's kind of cool in here. You can literally, up here on the top bar, you can say start simulation, and see the light turned on. I don't know if you can see, it's yellow. And if I flip the switch, the light turns off. I flip the switch again, the light turns back on. So this is part of what I want you to be doing with your circuit. Make sure that that it works. And then I want, ultimately, I want you to leave it on. And then there's the share button over here. Instead of getting a link, you're not going to turn in a link for this. I want you to download a little snapshot of your design. This downloads a file, and then you can import that file into a Google Doc, which is what I want you to turn in. I'm giving you a couple simple questions in a Google Doc. So that's our plan for today. I know I just